Hello, today we'll talk about chapter 1 of the textbook OpenStack. The title is Units and Measurement. Section 1 is the scope and the scale of physics. Section 2 is unit and the standard. I think we'll talk about only first section and second section. Okay, the first section is the scope and the scale of physics. So, what is physics? We can say that physics is about how nature works. So, we are trying to understand the natural phenomena and at all scales. So, we studied the microscopic world of subatomic particles and to the macroscopic world of entire universe. So physics is the most basic principle of science, and when we are doing science and physics, we try to make theories and the laws that explain how nature is working. And the terminology physics, it is from Greek physis. I don't know how to pronounce it, but that Greek word means the nature. So physics is about the nature, how nature is working, and we are trying to understand the, the fundamental mechanism that underlie every phenomenon. We say that physics is the exact science, and when we do science, we need to measure some quantities. So it can be measurable, and those measurable quantities are called physical quantities. And in this Fisi3171, this is about mechanics. In this mechanics, we are mostly interested in length, mass, and time. So these three quantities are called base quantities. We'll talk about this later more. But so we need to measure length, mass, and time to describe natural phenomena. Figure 1.3 shows some interesting images. The figure 1.3a is the, the gold metal measured by scanning tunneling microscope, and we can see the individual atoms. And the atom has the diameter around 10 to minus 10 meter. So that is 0.1 nanometer. And here we have some ice crystal image. It looks very nice. And the scale is about 1 micron, 10 to minus 6 meters. We usually call this micron scale as the mesoscopic scale. So here, when you talk about individual atoms, this is called a microscopic world. And for 1 micron scale, we can call this mesoscopic physics, mesoscopic scale. And then we live in macroscopic world. So in the macroscopic world, the size can be centimeter, meter, and above that. So here, figure C shows the galaxies. It is expressed in terms of million light years. So this is the macroscopic world. This is a mesoscopic world, and this is the microscopic world. So let me talk about order of magnitude. Sometimes it is better to talk about some overall size instead of the exact size, when the exact number doesn't have specific meaning. For instance, let's say we measured something and then it is 450. Then you say that it is about 10 to 3. So when we talk about some number in terms of power of 10, we call this order of magnitude. So we can talk about approximate some magnitude. So let's look at the table for the length, mass, and the time. You remember in mechanics, that's the topic for Fisi3171. We have 3 base quantities: length, mass, and time. So these are the different scales. For the length, I want to emphasize that the diameter of a hydrogen atom is about 10 to minus 10 meter. It is 0.1 nanometer. And the diameter of the Earth is about 10 to 7 meter. It's about 6, I forgot the exact size, but 6,000 kilometers, something, the radius. And the Milky Way diameter is about 10 to 21 meters. So we have very different numbers for different lengths. For the mass, we are using the kilogram unit. We'll talk about the unit later. The mass of the proton is about 10 to minus 27 kilogram, and the mass of electron is 10 to minus 30 kilogram. mass of the Earth is about 10 to 25 kilograms. Let me look at the scales for the time. These days, time can be measured very precisely, very accurately, and one day is 24 hours. In terms of the second, it is about 10 to 5 seconds. And human lifetime is about 10 to 9 seconds. So in physics, we are trying to understand the natural phenomena and what's the law which govern the natural phenomena. So we are trying to the law in physics. And when we try to understand the natural phenomena and natural law, we are using the observations. So measurement is the most important thing, the cornerstone. So we do measurement and then we can discover how nature is working. So physical quantities should be measurable. If any quantity which cannot measure, it cannot be physical quantity. So this is Enrico Fermi. In physics, we have Enrico Fermi Prize for best physics student. That's the prize. And this is Madame Curie. You remember, she got the Nobel Prize in physics. So we are trying to understand how nature is working. So we need to invent some theoretical model which can represent how the nature is working. So that is called a model. Figure 1.6 shows the Bohr model for single electron atom. So we think that atom consists of a proton and electron. So this is a simple model, and it was proposed by Bohr, and he got the Nobel Prize for this contribution. But this is just some approximate model, and it's not exactly correct. Nevertheless, it helped us to understand the physics law. So he got the Nobel Prize, and this is one example of model in physics. Theory means theoretical model for natural phenomena, and it should be confirmed by experiment. When the model is proven in general, then we call the model a law. So the law is a general statement that apply to nature, that describe phenomena in nature. we'll talk about Newton's law of motion, and the second law is given by this equation: F equals to ma. So this is the one example of physics law. Okay, now let me talk about section 1.2, unit and standard. So as I told you, physics is based on observation, measurement. So physical quantities should be measurable. If any quantity which cannot be measured, then the quantity cannot be physical quantity. So when it so when we measure physical quantity, we need to use some standard unit. For example, for length, we are using the meter unit. We have SI unit, which is called metric system. We have also CGS system and English unit, which consists of foot, pound, and second. So let me look at the SI unit. As I mentioned before, in mechanics, we have three basic quantities. They are length, mass, and time. For the length, we are using meter unit. For the mass, we are using kilogram unit. And for time, we are using second. From experience, physicists note that physics pursues simplicity, symmetry, and unification. So in physics, we want to see the simple picture, how nature is working. So in mechanics, there are many physical quantities. And among those many physical quantities, we choose three base quantities. They are length, mass, and time. And then there are many other physical quantities. They are called derived quantities. For instance, the velocity is the length divided by time. These are the base quantities for electricity and thermodynamics and quantum mechanics. But in physics 1, we are studying mechanics. So I don't want to emphasize these other base quantities. I think today this is good enough. So let me stop here. If you have any questions, you can send me an email, and then I'll reply. Thank you. Bye.